Hi everybody, my name is Mavis, and today we're gonna really talk about a really good topic with the title of the uses of hydrogen in petroleum refining. So with myself starting, my name is Mavis, and I will be continuing with my part, which is hydrogen definition, followed by the rest of the members. Hydrogen is the most common and lightest element in the periodic table. In its most common form, hydrogen has one proton and no neutrons. It is a colorless, highly flammable, gaseous element and the most abundant element, making up nearly 75% of the irregular matter throughout the universe. Even 10% of you is made up of hydrogen. Since we are in the topic of petroleum refining, I have some fun facts for you. Petroleum refining has the largest use of hydrogen, while the usage of gas in transportation and utilities are emerging in the current market as well. About 10 million metric tons of hydrogen is produced per year. About 58% of the hydrogen produced today is used to process crude oil into refined fuels such as gasoline and diesel, and for removing contaminants as well, such as sulfur from these fuels. Hydrogen is also used in a range of other industries including chemical production, metal refining, food processing, and also electronics manufacturing. This 14.5 times lighter than air gas can be produced commonly by steam reforming and electrolysis. If you look at the left part of the infographic, there is 4 methods to produce this gas. Steam reforming is a high temperature process in which steam reacts with a hydrocarbon fuel to produce hydrogen. Today, about 95% of all hydrogen is produced from steam reforming of natural gas. Electrolysis-wise, hydrogen is split from water using an electric current. Research is also underway to develop other methods used to produce hydrogen. These methods include using microbes that use light to make hydrogen, converting biomass into liquids and separating the hydrogen, and using solar energy technologies to split hydrogen from water molecules.
Hello everyone, my name is Ines and I'm going to talk about the advantages of hydrogen in petroleum refining. Talking about the advantages of hydrogen is a wide topic. It is an efficient energy carrier that is used to process crude oil into refined fuels. Hydrogen has a lower sulfur in fuels and the corresponding sulfur dioxide. It enables catalytic converters to remove other pollutants from transportation fuels. A good point about hydrogen is that it conserves precious natural resources by producing more fuel from crude oil, since it enables refiners to use all quantities of crude. Last but not least, hydrogen molecules store energy in combined form, which is very environmentally friendly.
Hi, I'm Fabrizio, and as you may already heard from my previous colleague that hydrogen has several benefits, and not several but a huge amount of benefits in our petroleum refining. But however, there are several disadvantages of hydrogen in petroleum refining, which I'm going to explain today. So, the first disadvantages of hydrogen in petroleum refining will be economically expensive for both fuel cells and the standard internal combustions. So, in real life, that both fuel cells and standard internal combustion engines that burn hydrogen are not predicted to be competitive in terms of price with standard fossil fuel until well beyond 2040. In terms of generating the electricity from fuel cell, it costs approximately $100 per kilowatt compared to $0.5 to $0.30 per kilowatt for standard fuels. And the current goals are to have a cost down to $35 per kilowatt by 2020. As for the second one, and it is considered as the major drawback of using hydrogen in the petroleum refining, will be to store and transport in a gas and a liquid form. As in gas form, it cannot be stored to make it of practical use, and it is also exceptionally flammable. As for the liquid form, hydrogen is much less explosive. However, creating liquid hydrogen requires cooling it in a tanks or compressing it, while the energy is three times using the gasoline. Which what I mean is that using the energy of hydrogen will be 3 times harder than that gasoline. The current technology only allows liquid hydrogen to carry 1/6 of the energy per liter than the standard gasoline. Some research has been performed on a special crystalline storage materials, but they are expensive. And the third one would be pure naturally formed hydrogen is limited. And compared to other gas, hydrogen lacks smells, which makes any leak detection almost impossible. And also, hydrogen needs to be stored under high pressure from the range of 350 to 700 psi. And lastly, the two main processes of hydrogen extraction are extremely expensive, which are the electrolysis and the stream reforming.
My name is Tara, and we're nearing towards the end of our video. But before that, I'd like to raise awareness of the main existing challenges in using hydrogen in oil refineries, despite being already widely applied in most refineries.
The application of hydrogen in oil refineries imposes several challenges that engineers need to overcome in order to ensure that all processes involved go smoothly, safely, and economically viable. Oil refineries produce a significant quantity of hydrogen needed for hydrotreating and hydroconversion processes, though in most cases, additional hydrogen is still needed, particularly for refining the sour crudes. Therefore, a hydrogen plant is needed on site to provide the additional hydrogen demand. Another challenge lies in reducing greenhouse gas emissions when producing hydrogen. As mentioned, additional hydrogen is much needed, and a hydrogen plant is usually constructed to supply the additional hydrogen. Within the plant itself, the most efficient way of producing hydrogen is through the removal from hydrocarbon. Often, this is accomplished through a stream reforming of natural gas in which steam at 700 to 1100 degrees Celsius is reacted with methane to produce carbon monoxide and hydrogen gas. Currently, energy input is greater than energy gain for this process. In addition, hydrocarbon fuel is needed to heat the water to create steam. Producing hydrogen from fossil fuels does not solve the problem of greenhouse gas emissions and does not end society's reliance on fossil fuels. On an economical standpoint, the increase in demand for fuel and oil directly impacts the need of hydrogen. Refineries need to keep up with the rising demand by increasing the supply of hydrogen. Hydrogen can be even more expensive to get, and the development of new, better, and more efficient technology in oil refineries that can consume less energy is futile in order to balance the cost of supplying hydrogen and the profits gained from refining crude oil. One may refer to the graphics shown to further prove how over the years, the production of hydrogen will continue to rise. The purple bars refer to the hydrogen produced from refineries, but again, the same trend in hydrogen production can be applied to other markets as well. Lastly, maintaining a certain degree of purity of hydrogen fuel cell is needed to avoid poisoning of catalyst. It is to be noted that naturally forming hydrogen molecules are extremely rare. Therefore, refineries alike need to go through extensive hydrogen gas purification processes to produce recycled hydrogen gas pure enough to be used for the crude oil refining processes.
Hello guys, my name is Gregorius. I'm going to tell you guys about the application of hydrogen in petroleum refining. Check it out.
So, what is the application or the mechanism of the hydrogen in petroleum refining? Hydrogen is usually used in the hydrotreating process in the refinery. Hydrotreating is a process where the crude oil is being treated by hydrogen to produce a higher valuable product. There is so many kind of activities in hydrotreating process, such as hydrodesulfurization. Hydrodesulfurization is a process where the sulfur compounds are hydrogenated to hydrogen sulfide, where it can be used as a feed for clothes plant. And as we know, sulfur is an undesirable component in the crude oil. So, there is another activities in the hydrotreating process. It is hydroisomerization. Hydroisomerization is a process where the normal paraffins are converted into isoparaffins to improve the product properties, such as RON. RON, known as research octane number, is indicate the behavior of fuel in engine at the lower temperature and speeds. Higher octane number will show that the final product have a higher value. And then there are also a dearomatization, where the aromatics are hydrogenated to cycloparaffin or alkenes. The last example in hydrotreating process activities is the hydrocracking. Hydrocracking is a process where the long-chain hydrocarbon are cracked to shorter chain in the gasoline range. It is also known as the catalytic process for converting the high-boiling constituent hydrocarbon into the lower boiling products such as gasoline, kerosene, and jet fuel. It has an objective where it wants to remove the feed contaminants such as nitrogen, sulfur, and metals.
Thank you very much for sticking around and watching this video until the end. The points that my colleagues and I have brought up will definitely give you more insights and improve your knowledge in using hydrogen in oil refineries. And we hope that through making this video, as well as the poster, that we can use the knowledge gained to improve the application of hydrogen in industrial scale in the future.